Video 1B, you're going to cover substitution, simplifying, and evaluating. So hopefully this is something you have seen before. This PEMDAS is a shortcut for remembering our order of operations. Okay, and what we're going to do is evaluate this expression. Evaluate means to find the value, figure out what all of this together is worth. And when we evaluate, we have to do it in this order. So I'm going to start on the left and work my way down. So P stands for parentheses. In this expression, there are no parentheses that have operations inside them, so that part is done. Now I go to E, which stands for exponents. I have an operation with exponents right here, so that is what I'm going to do first, 2 to the second power. Everything else is going to stay the same. 2 to the second power is 4. So this is my new expression. Alright, and over here, I'm doing my work on the left side, and on the right, I'm going to write an explanation of my work. So I'm going to write what I did. So I did 2 squared equals 4. That's where the 4 came from because I did my operations with exponents. Now, you might be thinking, Miss Beeks, that's dumb. Why do I need to write this stuff down? I know how to do this. That may be true. But this is a good note-taking habit, and that's what we are going to form in this class is good note-taking habits. And that is to have 2 columns, to have the work on the left side and an explanation of the work on the right side. Because at some point this year, we will do something that you have never seen before. And it will be very helpful in your notes if you have an explanation, so that if we have a snow day or a holiday break or even just a weekend and you haven't seen this stuff in a while, you have in your notes a reminder of why you did what you did. So I took care of the E, and now I'm moving on. M and D stands for multiplication and division. So I'm going from left to right, and whatever comes first, I'm going to multiply or divide. So in this problem, I have subtraction. I'm going to skip that, and here I have division. So 8 divided by 4, I'm going to take care of this operation, and everything else is going to get copied. Alright, 8 divided by 4 is 2. So I have 16 minus 2 plus 14, and again I'm going to write my explanation over here on the right. And this explanation is in my own words, so you don't have to necessarily copy exactly what I write. You need to write it in your words so that you will remember what you're doing. So if I look through the rest of the expression, there's no more multiplication or division, so that part is done, and now addition or subtraction. And it does not have to be in this order, it's whichever of these two comes first as I go from left to right. So I have subtraction first, I'm going to do that subtraction. And everything else gets copied, so the plus 14 comes down. 16 minus 2 is 14, so I did my subtraction. And now 14 plus 14 is 28, and that is my final answer after I do the addition. Our next example says to substitute and then evaluate. So evaluate is what we did in the last problem. This time we have to substitute first and then evaluate. So I have an expression here that has variables in it, x squared, y, and z to the third. Alright, if I don't have values for those numbers, I can't evaluate. I can't figure out how much it's worth. So they give me values. They tell me that x is equal to 4, y is equal to 5, and z is equal to 3. So what we're going to do is substitute. And think of it just the way you would in a sport when you have a substitute. One person comes off of the field and another person goes onto the field. They don't both stay on. Somebody has to come off before someone else can go on. So in this case, it's a soccer game, and number 10 is coming out of the game, and number 17 is going into the game. So in our expression, if x equals 4, x is going to come out, and 4 is going to go in. Alright, so I have 3, and then I'm going to replace the x with a 4 in parentheses. Whenever you substitute, you should write things in parentheses, because if I just wrote 3 and 4 next to each other, it might look like 34 squared, and that's not what I'm trying to do. Alright, then I'm going to keep going, plus 2, and now I have y, so I'm going to substitute. Y is going to come out, and 5 is going to go in, plus z to the third, so again I'm going to use my parentheses. I'm going to replace the z with a 3, so now I have 3 to the third power. Alright, and then we're going to do just like we did in the last problem. We're going to evaluate, we're going to go left to right, and we're going to use our acronym up here to help us remember. So parentheses. Now, I have parentheses written here, but inside the parentheses, I only have a single number. I don't have any operations. And whoops, I forgot to copy this down correctly. So now I do have operations inside the parentheses. So the first thing I'm going to do is simplify this set of parentheses as much as I can. So I'm on to my next letter, E. So inside the parentheses, do I have any exponents? Yes, I do. So I'm going to do that operation first. So the rest of this, I'm just going to copy. 2 times 5 plus, now I'm going to do 3 to the third power. That means 3 times 3 times 3 again, so that gives me 27. And I still haven't resolved those parentheses, so they're still going to be there. So I did the exponents in the parentheses. Now I'm looking for any multiplication or division in the parentheses. If I have a number beside another number in parentheses, that means multiplication. So again, I'm copying all of this because I'm just working inside my parentheses. 2 times 5 is 10 plus 27. So I did my multiplication, and now I have addition. So 3 times 4 squared plus 10 plus 27 is 37. And now I don't need to write those parentheses anymore because all that's left is a single number. So I took care of the parentheses. Now I'm going to go through this thing again for the whole expression. So do I have any more exponents? Yes, I do. 4 squared is 16. So now I have 3 times 16 plus 37. All right, that's taken care of. Do I have multiplication or division? I have multiplication right here. 3 times 16 is 48 plus 37. So multiplication, division is done. All I have left is addition and subtraction. 48 plus 37 is 85, and that would be my final answer. All right, for this next example, what I would like you to do is pause here, try this example on your own, and when you come back, I will show you the answer. Okay, so you should have got a final answer of 23. Check through my work compared to yours. If anything's different and you can't figure out why yours is a mistake, make sure you make a note of that. Maybe stick a post-it on your notes so you can ask about it in class. You are also going to try that last example by yourself. All right, so the example that's right on the bottom, you're going to do that yourself, and we'll talk about the answer in class. All right, we have a problem here. John burns 420 calories per hour skating, and it tells you how long he went skating over the weekend, and want to know how many calories did he burn in total. There are 2 different ways that we could solve this problem. The first way is we could say, well, he went skating for 3 hours on Friday, plus 2 hours on Saturday, plus 2.5 hours on Sunday. And if I multiply all of those hours by 420, that would tell me that he was skating for a total of 7.5 hours, which means that he burned 3,150 calories. All right, that's one way to solve that problem. A second way to solve that problem is to say that on Friday he burned 420 calories for 3 hours. Plus, on Saturday, it was 420 calories for 2 hours. Plus, on Sunday, it was 420 calories for 2.5 hours. And again, if I multiply all of these out, I get that he burned a total of 3,150 calories. That is an example of the distributive property. This 420 calories got distributed to each of the different amount of times that he went skating. All right, so the distributive property gives us a way to solve problems when we can't simplify in the parentheses. So here I had all numbers, I could add them up and then multiply just one time. But sometimes you can't do that. So we need a way to be able to simplify things even if everything inside the parentheses is not the same. So when we use the distributive property, we're going to take what's on the outside and we're going to multiply it by everything that is on the inside. So here I'm going to multiply 7 times 3w. And I'm also going to multiply 7 times -5. And I'm going to take that minus sign as a negative. All right, if you do that, it will make your life so much easier as far as keeping the signs straight. So 7 times 3w, well 7 times 3 is 21. So now I have 21 w's. And then 7 times negative 5 is negative 35. So that would be using the distributive property to give me a simplified version. Example B, don't let it scare you just because it looks a little different. The 4 at the end is exactly the same as the 4 at the beginning. I'm going to multiply it by every single thing that is in the parentheses. So I have 4 times 6v squared plus 4 times v, and then 4 times negative 3. 4 times 6 is 24 v squareds. 4 times v is just 4 v's. And 4 times negative 3 is negative 12. Alright, you're going to pause here and try that last example C on your own. Alright, last thing we're going to look at is like terms. Alright, like terms are terms that have the same variable, or if there's more than one variable, they're all the same, and the same exponents. And this is important because you can only add or subtract things that are like terms. Okay, so examples of like terms. 2x and 3x would be like terms because they have the same variable. 4x squared and 2x squared would be like terms because they have the same variable. Alright, same variable, same exponents. Things that are not like terms, 2x and 3. We can't put those together. That doesn't make 5x because this doesn't have an x. 4x squared and 3b squared. Those are not like terms, even though they have the same exponent, they do not have the same variable. Alright, what I would like you to do is put in 2 more examples and 2 more non-examples, so make up your own. And then we're going to look at simplifying things by combining like terms. So when you do this, what I would like you to do is cross things out as you go. So if I look at this thing, the first thing I have is 4y to the third. There are no more terms with y to the third. So I just copy it down and then cross it out because it's done. Alright. Next thing I have is 2y. And I also have this term that has a y just by itself. So I'm going to combine these two terms. And when I combine them, all I'm going to do is add or subtract the numbers, whatever it says. So I have 2 minus 8. 2 minus 8 is negative 6, and then I'm going to leave the y exactly the same. So I add or subtract the numbers, leave the variable just like it is, and I cross that out because I dealt with it, and then I have this plus 5 at the end, and it just comes right down, follows me. Okay. Example B, the first thing I have is 7m, so I have a 7m, I have a plus 2m, and I have a plus 4m. They are all like terms because they're all m's, so I'm going to add them together. 7 plus 2 is 9, plus 4 is 13, so I now have a total of 13 m's. I'm going to cross those out, and all I have left is this 5p. It can't go together with m's because they're different letters, so I just copy it right down. You have one more example there that you're going to do on your own, and then that'll be it for 1B.